Oh, hi. What's up, Five Keys? Mr. Mike here. So we are starting our algebra course with the third unit in bridging to algebra, the pre-algebra course. But don't worry, I'm going to give you algebra credits. But I really want us to have a solid foundation as we move into the more advanced algebra stuff. So we're going to start a little bit further back. And then when we get together as a group, we'll integrate more algebra so I could give you those algebra credits. Um, but this stuff is awesome. So you ready? Let's talk about it. How this is going to work, I'm going to make these silly videos that you're going to hate watching, but you're going to do it because you love mathematics. And don't stress out if you have questions or if I'm going too fast. That's what class is for. But I want to introduce you to the topics. Make sure you're watching and coming in with your questions all ready to go versus starting from square one when we meet together. All right? So here it is. Um, Integers are positive and negative whole numbers. We will talk about this one as a group, this system here. Um, but these are examples of numbers that are integers. 0 is an integer, -3, integer, 196, integer, -26, integer, 7, integer. Notice there is no decimal component or no fractional component. They land square on the whole number. The only difference, the reason we don't call them whole numbers is whole numbers are meant to only be positive and 0, I think. Yeah. Um, so we need another name to come up with for when we start talking about negative numbers as well. And we call those integers. So all the numbers from negative infinity to positive infinity that don't have a fractional or decimal component are called integers. That's so awesome. Okay. These are not because they have decimals and fractions. So let's talk about more about negative numbers. I want to say something before, which is it is kind of a brilliant part of mathematics later, but really frustrating at first, that the negative number looks the same as a subtraction sign. Um, you will develop a fluidity and understand why it's kind of brilliant a little later on. But at first, it could be kind of aggravating because you're trying to distinguish between the two. So in this case, 2 minus 1, let's say, this is not a negative sign. This is a subtraction sign. It's a verb. It's an action. It's something that we do to the numbers. Think of it like we call them operators: add, subtract, multiply, divide. This here is a negative sign. It's -3. This is a number on the number line. It's saying this is not, let me see if I can find this is not this number, but it's this number. It's to the left of 0 on the number line. It tells us location. It's like an adjective. And yes, it is confusing that they are exactly the same, but it becomes brilliant later on. You're just gonna have to trust me like on that. Back to the packet. What is your bank account balance if you withdraw or if you withdraw money than you have in the bank? I think that word's supposed to be more. Um, and in this case, they're making a point because it's a very negative point that your balance is in the red. It's negative $237.29. That's money that I owe. That's why we use this negative sign and why we need it. Okay. If the temperature gets colder and colder, what happens after it reaches 0? Same idea. Here we have uh, a -11 degrees on this thermostat in Celsius anyway. And we need the negative sign to denote that it's below 0. Both situations above are applications of negative numbers. Negative integers are opposites of positive numbers. They represent values less than 0. Negative numbers can be placed on number lines. When the number line is drawn horizontally, the negative numbers are usually drawn going to the left, starting from 0 as shown below. Notice everything to the left of 0 here is a negative number. And they are counting, well, they're counting down, but the negative is getting more negative as we get away from 0. as it gets more positive as we go up. And we may be familiar with this from seeing rulers, but this is just a ruler that's it's zero with flip to include the negative numbers. All right, what else we got? When the negative line is drawn vertically, the negative numbers are usually drawn going down, starting from zero, as shown in the thermometer above. Bloop. Note zero is neither positive nor negative. And that's something that comes up on testing sometimes. Zero does not have a value. It's not negative, it's not positive, it's nothing. Comparing integers. When comparing integers on the number line, the integer that is farthest to the left is the smallest integer. For example, -6 is less than -2 because it is to the left of -2. Okay, this is a really important concept that I want you to think about. And it's important and a little confusing because it's not how we use language in life. If I'm in debt $1,000, I owe $1,000, and my friend is in debt -$500, -1,000, we would never say I have less debt than my friend. Because we think of -1,000 as being a greater number than -500. But in academic mathematics, which you're studying for this GED or whatever it is that you're doing, we always refer to the number to the right of the number line as the greater number. So in this case, the Pac-Man wants to eat the -500. It's a bigger number in quotation. So for instance, -3 is greater than -10. Um, a 4 is greater than -8. All right, even though this might challenge our intuition a little bit, it's very important to recall that. Okay, bloop, bloop, bloop. Okay, this is a great question. Using the number line above to help us, we can see the coldest temperature is -6 degrees Celsius. This is this little thermostat, this little temperature chart they gave us here. Help us. Okay, and the warmest is 5 degrees Celsius. The correct order is -6, -5, 1, 3, 5. And we could confirm that by saying -6 is here on the number line. This is Tuesday. My next coldest is Friday at -5. See how it's 1 to the right? The next coldest is Thursday. That's 1 degree. Monday is 3. And Wednesday is 5. So notice how we're consistently going to the right as we go up. So this is the order of the temperatures from least to greatest. This is another very important concept, the idea of absolute value. So when we do want to talk about numbers in terms of in the way that we do casually, like if I wanted to say, hey, my debt of $1,000 is actually greater than your debt of $500, we use this magical symbol called the absolute value sign. I frame it in between two bars. So when I do that, when I frame the negative number or the positive number for that matter between two bars, I'm all of a sudden talking about distance from zero. And I always express distance as a positive number. So in this case, -600 is 6 units from zero. The absolute value of -6 is +6. The absolute value of +6 is still +6 because I'm only concerned about distance at this point. So if you see this symbol, absolute value, the two bars around the number, remember, it turns any negative number into a positive number. And if I were to frame a positive number in this way, it wouldn't do anything to it. It would stay exactly the same. As you can imagine, this gets a little wild when we get variables involved with that. But when you're dealing with pure numbers, don't let this one confuse you. All it does is it takes the negative number, it turns it positive. And if it happens to be around a positive number, there's really no reason for it to be. But if it is, it keeps it positive. Okay, find the value of negative 14. 14. Write the numbers in order from least to greatest. Oh, I like this. So we have to do a little bit of math. Negative 19 is 19. 12 is 12. I'm just going to do the math first. The absolute value of 21 is 21, and negative 3 is negative 3. Least to greatest, negative 3 is all the way to the left of 0. So we know that one's going to be first because it's the only negative number on the block. And then the other ones are just in order. Use the number line above, write the integer for each point, then give its opposite. Okay. Oh, we didn't talk about opposite. Okay. I'm going to talk about opposite and then be done, and you can take a break. Um, Opposite numbers. Uh, we use this term opposite to mean a number that is uh, has the same absolute value, but is on the other side of the zero. So I'm opening up a whiteboard, which is why I'm stalling for the computer to be able to do this. What does that mean? It sounds super confusing, I know. If I'm at negative 5, this is 5 units away from 0. The only number that's the same length from 0 on the opposite side of the 0 is a positive 5. So the opposite of negative 5 is 5. The opposite of negative 100, positive 100. The opposite of 100, negative 100. Here's a challenging question for you. What's the opposite of negative 100? Ask that question when you're in class. Okay. Whoops. Whoa. Stay with me. Okay, that's it. I pulled this back up. I'm done with my spiel. You're going to do this practice section on your own. Um, Give it a shot before we come to class, okay? Again, the idea right now is not full mastery. Just give it a shot, look them over, and then come to class with your questions and we're ready to go. All right? Cool. That's your first one. You're all done. Going on to number 2 in a second here. I meant to pause, stop it, not